Today, energy is one of the most important challenges in our world. We know that energy management has become a real problem in our society. Whereas the amount of fossil energy decreases critically, our consumption increases hardly. The remaining resources on Earth won't be sufficient. The solution? Renewable energies. Photovoltaic energy is one of them and probably the most promising. In the future, we will need to handle with it. We walk down the street to know what population thinks about it.
Quand même.
Oui.
Ouais, c'est une bonne idée, mais pas nécessairement accessible à tous.
C'est une bonne chose pour la planète, on va dire.
Ça peut être bien.
Ah, je ne sais pas, mais c'est souhaitable.
Mais j'espère, ce serait super.
Malheureusement, on constate que dans le monde entier, la consommation d'énergie continue à augmenter tous les jours. Donc première chose, la consommation d'énergie, c'est un vrai problème. En tout cas, ce sera un mix énergétique qui fera que demain, on pourra trouver une solution à ce problème dramatique, tant de la pollution que de la consommation d'énergie.
Being aware of this problematic is a good thing, but acting in order to change it is something extremely different. Solar Owning is a brand new Belgian enterprise founded by a group of engineers in order to offer a good answer to the question, how can we handle this? Here is what they figure out being a good solution.
It isn't easy to set lots of solar panels in cities. It's why we have to take every little opportunity to catch the power of the sun. The solar awning solution is a solar outdoors awning. Its efficiency is double because it allows to protect us from the sun and to generate energy. Moreover, this technology fits very well to Belgian climates because it's enabled to produce energy with very low brightness. The solar awning is a flexible panel which is designed to put on many surfaces. It can be used as well in big cities as in rural places. For instance, in big cities, a bartender who owns a bar with a terrace can use it to create electricity even though the place is less exposed to the sun. Another example, such awning would be very useful for camping car. In those cases, the solar awning is the solution. Now, let's take a look about how light can be changed in electricity.
In every material, electrons that compose it have different levels of energy. Some of these levels are permitted, others are prohibited and named band gaps. In every atom, there is an alternation between permitted and band gaps. Electrons can never stay in a band gap, but they can jump from one permitted band to another. The band where a valence electron stays is called valence band, and the next higher band is called the conduction band. If electrons are in the conduction band, a current will be created.
The de Bruyn's theory explains that light is a particle wave, which means that it is made of photons. When one of those hits a photovoltaic surface, it transmits its energy to electrons that are in the panel. So, these electrons switch to their excited state. Because the materials are semiconductors, those excited electrons will be able to jump to a band of higher energy, the conduction band, and then conduct electricity. But because the displacement of the electrons is hazardous, it's hard to produce a net current. To solve this problem, we use doping.
Doping is the principle of mixing impurities with the semiconductor used in the panel. There are two kinds of doping, the N-type for negative type and P-type for positive type. In N-type, we had pentavalent atoms such as phosphorus. Thus, an N-type layer of silicon contains an excess of electrons. This layer becomes negatively charged. The P-type is the opposite. We had atoms that only have 3 valence electrons, such as boron. Thus, a P-type layer of silicon contains a lack of electron. Holes are present in the structure and the layer becomes positively charged. A photovoltaic panel is composed of 2 superimposed layers of silicon, respectively N and P-type. Put together, an electric field is formed between the 2 layers. Some free electrons from the N-type move to fill holes in the P-type. But not all, because a potential barrier is created between the 2 layers and the system acts like a diode. Electrons are now free to go toward the N-type layer only. When a photon gives its energy to an electron of the N-type layer, this electron will go to the upper face of the panel. while the hole associated will go to the bottom of the p-type layer. Electrons will then be harvested by a conductor for exploitation.
In amorphous silicon, there is no order in the atom's arrangement. This absence allows catching more light, but charges are more difficult to move. Amorphous silicon cells are composed by pin junctions. It's superposition of 3 layers, one p-doped, one n-doped, and a neutral layer between them. Those cells have the advantage of being flexible and reacting with weak brightness. But in fact, is this project really profitable?
Amorphous silicon is a technology based on the silicon, which is the most abundant element of the Earth's crust after oxygen. Furthermore, the abundance of these materials will not increase the cost of the product. The amorphous silicon cells are not manufactured with toxic elements such as cadmium, what makes these cells more eco-friendly. This technology also has a major advantage because it works in low light.
Bah moi j'étais vraiment séduit.
Une très bonne idée.
Oh, c'est une super bonne idée. C'est révolutionnaire.
Ce serait beaucoup plus discret à mon avis.
Ça passe très bien dans le paysage.
Je pense que c'est un projet très intéressant.
This technology distinguishes itself thanks to its flexibility. Indeed, solar awning is only based on the retractable solar awning, but it will spread out in the future to all surfaces which need a flexible solar panel. The panel may be well included in the landscape of the city. They could also take place on the roof of houses, on the roof of shops, on walls or on windows. The public we want to reach is very broad, because these panels are suitable for both large and small communities. Indeed, it is the main opinion of our population sample. You've got the power of change.